When you are making energy savings or what we call energy management opportunities, you have to know that you have made a difference. You also have to know that a change needs to be made in the first place. You can't just go saving energy without knowing, well, how much energy do you use right now? And then going forward, you want to say, well, how much energy did I save? Basically, how much money did I make this company? How much can I charge them for my services? So, an energy accounting system is used for this. The energy accounting system does three things. First, you benchmark. Benchmark means how much energy are you using right now? And then you make some energy management opportunities happen and you record how well did you do. You're hoping to make some positive changes and you want to have some targets to achieve and you want to measure to get to those targets. And then so this is like a cycle of saying, well, now let's benchmark again and see where we are. So this is a process we go through, and there's quite a few standardized energy accounting systems that we can use. But first we have to figure out, well, how do we do our calculations in the first place? So before we can go and benchmark, we have to know in general just how we do accounting of energy. So I'm showing you this first example, and we use the tables 1 and 2, these tables 1 and 2, to be able to calculate, well, how much is our energy costing us? So here's just a very general example for you. Electricity has a certain cost per month. If 100% of it is converted into heat, how much would that cost in dollars per gigajoules compared to if it had an efficiency of 82%? So here, the big takeaway for us is, how do we calculate that cost of electricity? Well, the cost of electricity is the dollars per kilowatt hour. Now, what's a kilowatt hour? Kilowatt hour, is that power? No, that is energy. So that is an energy cost per dollar. It's a dollar per kilowatt of energy. Well, how much energy did we use? And if we multiply the amount of energy we used, then we could get the dollar per amount of energy. But this question, I'm just illustrating to you how to get the dollars per amount of energy that you used. So these are just simply conversions from table 1 and table 2. We know that it's this amount of dollars per kilowatt hours. Then how much would that be per gigajoules? So this is a common conversion that what you'll have to do in many questions or many situations in the real world is you'll have to take that kilowatt hour and convert it to gigajoules to be practical. And in this question, I'm also showing you how efficiency works. If you are reducing the efficiency down to 82%, that's going to increase your costs. So going from 100% to 82% of using this energy makes your cost per gigajoule go from $18 up to $22. So let's look at another general accounting question. In this one, I'm showing you how to figure out the dollars per gigajoule of different types of fuels. So we have natural gas, $4 per ton. That is actually around about the price that it is realistically in Ontario. And then you have the cost of fuel oil, which is $125 per ton, which is a little bit lower than it is in Ontario. So you can see that this cost of natural gas and the cost of fuel oil are measured in the same units of dollars per ton, but the efficiencies are different. So The efficiency of burning natural gas is 90%, but the efficiency of burning fuel oil is only 78% in this question. It's actually lower in reality. So again, you need to apply the efficiency to this. And if I convert to dollars per gigajoules, and sorry, this natural gas is supposed to be per gigajoule because we didn't have to do any conversion here. So I can just say reduced by the efficiency factor. This $4 per gigajoule is actually 4.44 per gigajoule at 90% efficiency. Fuel oil, a little bit different because I need to convert from dollars per ton to dollars per gigajoule in order to be able to easily compare it to our natural gas example. So I want dollars per gigajoule, dollars per gigajoule. I'm comparing apples to apples. Here I need to take my dollars per ton, and then I need to do all of these conversions from table 1 and 2 in order to get dollars per gigajoule. But fuel oil, I'm saying, only burns at 78% efficiency. So then I reduce that further and I have $3.81 per gigajoule. So now, since they're both in the same units, I can compare them both. In this case, fuel oil ends up being cheaper. In reality, in Ontario, fuel oil is actually more expensive than burning natural gas, which you probably know from your experience.